So hi guys, this is Chris from DoraHacks. Welcome to the very first EVMOS extension hackathon workshop. Today we are very happy to have Dan which is in the EVMOS product team to join us. He gonna give a speech about how to get started. How as a developer, how can you get started on EVMOS testnet? And maybe a little bit more about the uh, most updated technology about EVMOS recently that developers can tackle. So yeah, Dan, feel free to start when you're ready.
Okay, awesome. Hey guys, I'm Dan from EVMOS. Today's workshop is about getting started on the EVMOS testnet. I'm gonna just present my screen to kind of guide you through what you can do on the EVMOS testnet as a developer. So let me just confirm that this is working. All right. So if you need a little bit of context, just generally, like we started officially already. We're in the progress of this hackathon, the online hackathon. It's called EVM extensions because this is one of the new functionalities that we've recently deployed to the EVMOS testnet. The hackathon is not exclusively focused on the EVM extensions. You can also get some prizes that are like you see it here for like DeFi focus or infrastructure, for example. But the biggest ones are definitely for EVM extensions. And for the people that also don't really maybe know exactly what EVMOS is about, we're a layer one Cosmos chain in the Cosmos ecosystem. And we basically built EVMOS to combine the best out of the EVM world and the Cosmos world. And so far, you as a developer were able to deploy smart contracts on the EVM on EVMOS that are compatible to any other EVM. So you could take an application on Ethereum, for example, that exists, and just take those smart contracts and deploy them on EVMOS, and they would work. But the cool thing about the Cosmos ecosystem is that you have a bunch of dApp chains, and you can imagine they all are, most of them are really application specific. So they might, for example, like Osmosis, they have just a chain for making the best DEX. And the whole protocol is focused on that, and it has its own governance. It's kind of sovereign. The same way EVMOS is focused on providing EVM composability. And with EVM extensions, or prior to EVM extensions, smart contracts on EVMOS were always isolated to the EVMOS network. So you could write programs with smart contracts that could talk to other smart contracts on EVMOS, but they couldn't really leave the EVMOS network or tap into protocol native functionalities like staking and voting and such. And now with EVM extensions, we are extending the access of the EVM and smart contracts for protocol functionalities, as well as IBC, which is the protocol to connect to other blockchains. And this is actually pretty unique in the Cosmos ecosystem because it allows you to build cross-chain applications, as well as a bunch new use cases that are using staking, governance, like I mentioned. Right now, I'm going to show you just how to get started on testnet. The current version on testnet includes staking and distribution EVM extensions. So you can already use smart contracts to stake tokens, to make a staking indexer or manager that always restakes your tokens or only claims the pending staking rewards maybe when EVMOS price is at a certain level, like for tax efficiency. There's a bunch of ideas that you could get into, and we're going to have another more extended workshop on that tomorrow. But today we're just going to give you the the intro on actually how to just generally work with Testnet. And I've prepared like a little overview here that we're going to follow and run you through how to connect to Testnet using MetaMask wallet. Use our faucet to just like, if you don't have any test Evmos, then you can get some free Evmos so you can start actually broadcasting transactions for deploying your contracts. And then we're going to use Remix to actually deploy a contract. It's quite easy. I'm going to also give you a example contract that you can follow, and maybe I can also share this notes after the stream. And then we're going to use one of the block explorers on Evmos, which is eScan. It's deployed on and also indexing all the transaction on both testnet and mainnet. And then kind of like a plus, if we have time, we'll see how far we get. We can also use the CLI, so the Evmos binary, to do this from the command line, like querying, at least like querying balances. But yeah, we'll see how easy it actually is with Remix. Let me just close the window because it seems like it's very, very loud here. 1 second. Not sure if that helped. Okay. All right. So then let's get started. So first thing, or just to summarize, like we're gonna basically, our goal is to deploy a contract and like use a block explorer to understand what's happening. So for that, we're going to use MetaMask today, and I already have MetaMask installed. You can go to our documentation as well at evmos.dev or docs.evmos.org. And there's a bunch of different sections, also about like connecting your wallet, and it will run you through like actually installing MetaMask if you don't have it yet. I already have it fortunately set up with like a dev account, so this is just my test account. And this is also the place where you can connect to Testnet. So if you're not really familiar with it yet, you can switch between different networks. So these are different like node providers to different networks. Let me choose just another one to show you that if I even delete the testnet to start from scratch, that's gone now, then I can go connect to testnet here. This opens up Chainlist, which is just a registry of different RPC node providers. Those are basically nodes that let you communicate with the blockchain. So either submit transactions or query anything that's on the state of the blockchain on Evmos. And this is the testnet one. So I can connect my wallet here. It's going to just give you the information and the exact endpoint, as well as the chain ID. Note that the mainnet one is actually 9001. And the denomination of the token on testnet is TEVMOS. So I can prove this. This is just going to tell me that switching from the currently selected one to the Evmos testnet. And now we should see we're also connected to the testnet. So that's step one. Pretty easy here. The second one, you see that I do have some test tokens on here already. If I was to select any other account, let's take just another one. That's probably for you how you would start. Then you can go to our testnet faucet. This is just running through some like verification that you're not writing a program to just do this automatically and empty the testnet faucet quickly. So what this asks me to do is I can copy my address and enter this here, or I guess I can also request directly from MetaMask and send the tokens. And then you see you get like 0.1 tokens, it says here. Let's see, actually might take a while to update. Oh, there we go. So now that we have some tokens to play with, we can actually deploy contract. But I'll go back to the one that has way more, just in case I make any mistakes and send all my tokens somewhere else. And I'm actually gonna move this down here. So now we are pretty onboarded already to Evmos, which is great. We've got some tokens. Next step is actually going through the deployment of a contract. You can do this in many ways. You can do this by writing a script in Go, in JavaScript. There's a bunch of clients that let you connect to like a Geth endpoint, so Go Ethereum endpoint, to connect to the EVM. The easiest way to do this, though, also to showcase it to you, is using like these tools like Remix. So let's check that out. So Remix is basically a great interface for you to work on smart contracts and deploy them or compile them with a Solidity compiler, and deploy them on any kind of network that's EVM compatible. Let me just go to my basic new one. Okay, so I actually wanted to go to my default workspace. So this might look different for you, but it doesn't really matter. So what we want to do is we want to take the code of a ERC20 smart contract and deploy it on Testnet. So we do have one contract on our main Evmos repo. This is actually, for the people that are interested in what this actually is, this is the contract that is automatically deployed whenever a token is whitelisted on the Evmos protocol, because on Evmos we always have two representations of tokens. It's either the IBC coin or it's the ERC20 representation. Those are just two different token standards that have different interfaces. The ERC20 one is coming from the Ethereum world, the IBC token standard from the Cosmos. And on Evmos, there's a governance process to whitelist these contracts. So if anybody whitelists IBC coin, then the protocol will automatically deploy this ERC20 representative. So we can always like switch between the representation of it. So what we're going to do here is we're going to copy this contract. I might have already done this, actually. Check. I don't think so. Okay. So then let's take the name from here. You can give it any name. And then we're going to copy this contract. Just gives you a notification that you've copied the contract, and should be careful what you're doing. In this case, you also want to get rid of the direct import here. Remix knows about OpenZeppelin, which is basically a great library for like the standard ERC20 contracts that you can deploy. And this one in particular is like an extension of this, the ERC20 contract, the standard on OpenZeppelin, and it allows you to set the amount of decimals that the token will have. I'll explain this to you later, but just so you know. And it also allows the owner, so the deployer of the contract, to mint or burn tokens, and that's kind of the setup of the rule in the constructor function. So now that we have this implemented for our file ready with the contract, we can go to the compile section. I believe you have to like select this one and then it knows it's the right file, and this is successful. If it's not successful, then you maybe have forgotten to change the imports or something else went wrong. But the compiler will check the correctness of I guess the solidity grammar, and if it compiles correctly, you'll see the verification here. Next step is we want to select the network that we want to deploy on, and I guess the environment it's called here. And we want to use injected provider MetaMask because this allows Remix to communicate with the network that is currently selected on MetaMask. And you already see the 9000 chain ID that I mentioned earlier for the Evmos testnet, and everything looks all right. It also says which account it is selected right now. Don't mind that it says Ether. That's just because this tool is also mainly used on Ethereum, but it's actually compatible to any other EVM. And this also aligns with the address here. So there's a bunch of other contracts that are imported here in this project. It doesn't really matter. Just choose the one, this ERC20 Minterburner decimals contract. And now we can deploy our first contract on testnet. So we can give it a name. We can call it Dora tutorial. And then our contract token or symbol is Dora. And then I'll give it 18 decimals. And that's just the, I guess, the standard of ERC20 tokens. There's, in the Cosmos world, it's kind of up to the chain to decide how many decimals the native token at least has. But I'll just choose 18 because that's also how many decimals are on Ethereum. And once we have this, we can transact, and it'll open the gas settings that you can change if you like. And then we hit confirm. Happy with this. And then on the bottom, we should see the confirmation. If something hasn't worked out, maybe your gas settings were wrong and you can try to adjust them again. But yeah, this basically gives you, this a bit bigger, gives you a status, a transaction hash, which is important for the block explorer. It says the origin or the sender of the transaction, and the actual function that is then applied, and gives you basically a whole like encoded, decoded output of all the data of the transaction as well as the logs. But we'll also be able to see that in the block explorer afterwards. Awesome. So maybe actually we can, we'll do it afterwards. So once you've deployed it, you actually can access all the different functionalities or functions of that contract. So we can see this one actually inherits from the standard ERC20 contract, which has a bunch of functions like minting, but it also has additional ones like, I guess, decimals, and a bunch of queries. So the blue ones are the queries. What we want to do is just demonstrate how you can actually use one of these functions. So I'm going to mint some of these new Dora coins to my own address. Like I said initially, I'm the contract deployer or the contract owner, especially, or at least this account. And so I'm the only one who's has the minting role for minting new Dora tokens. So I'll just copy my deployer address here because I want to send myself some tokens, and I want to now mint any amount of tokens. And because we had 18 decimals, this means like if we want to have, let's say, 40 Dora tokens, then we would have to add additional 18 zeros. So hope I did that right. And then we want to actually perform this minting transaction. So we'll see MetaMask popping up again, confirming that. And then consensus is happening, block is built, and we successfully executed this minting transaction. Also, by the way, MetaMask also allows you to kind of like follow your transactions here. We're going to get into that in a second, but before, just to confirm, we can also now query the balance of anybody or any account that might have Dora tokens. Mind that you're you're basically calling the balance off function of the smart contract that only knows about the Dora tokens. So that's the only output you're going to get, not any other ERC20s. So put this address in here, do the call, and we see successfully this answers with like 40. If I put any other, I guess maybe that's a stupid example, but yeah, just to confirm. So we have the 40 that we minted before. Another way to confirm this is actually you can show the assets on MetaMask. So I've done this before. I actually deployed a contract called Dan, but to show you how this works, you can import the token and it asks you for the contract address, which you can get here on the copy. I'll do that again. So import tokens, and you'll see it actually realizes that this is the token symbol and the decimals added, and it already sees the balance. And clicking back here, I can see this new asset, and I could also send Dora token to anybody else. Maybe create a market for it. So this is, that basically is the magic already to deploy a contract on Testnet. Now, yeah, we've done this step. Now what we can also look into is actually diving a bit deeper into understanding, the contract calls and using a block explorer. And for that, there's a bunch of block explorers on Atmos. The most important ones, or I guess most used, are eScan and MintScan. eScan is quite good for both EVM and Cosmos transactions, but it's primarily used, I'd say, for EVM purposes. And when we actually added our MetaMask, it also automatically adds a link or a reference to the eScan block explorer as default. So what you can do is check out the recent activity, and let's say we've got the contract deployment, and it actually stores the information here of the contract deployment, and you can also click on status beyond block explorer. Okay, this is the old one. I guess I didn't do that right, so let's do it manually. So this is the testnet eScan. This is actually an older one. We also have, evm.atmos.dev, but this one is a bit slower with indexing the data, so the hash is actually not available at the moment. But going back, let's grab the transaction hash. Maybe we do that directly from the deployment. You can also do it here. Perfect. And we see the actual transaction. Generally, the Block Explorer allows you to do a bunch of things. You can basically view a bunch of data on the blockchain, specifically here the testnet. So like I mentioned, there's EVM, Cosmos transactions, validators, a bunch of different types of tokens and the logs. And now we're specifically in the deployment transaction, and this is pretty neat. It actually realizes that this is the Dora tutorial contract that we deployed. It's ERC20 mint. I guess, sorry, this was the mint function call. I copied it wrong, but that's also works. So we have the mint functionality here, and it also shows actually the input that happened during the contract call through MetaMask, as well as any logs that are there. In this case, it's also doing the transfer and yeah, basically giving you all the information. So if you have smart contract calls that are going a bit deeper, where you might have a proxy contract that calls another contract and calls another contract, all of these logs will appear here in the Block Explorer and are extremely good for debugging your contracts. Let me just check what else we can show here. Maybe if we actually check out the contract address itself, it's also possible. So like I mentioned, you can copy the address here, go back to testnet, and this is now the main page of the contract. Again, we have the symbol, the address, decimals that we customized, and then it actually also shows a history of all the different transactions that were that interacted with this contract. So we have the initial deployment. Maybe that would have been the faster way to get to the transaction. So here we have the creation, so the instantiation of the contract. This will hold more topics and logs. Mainly for the instantiation, it has like the rules that you can also see in the contract itself. As I mentioned in the beginning, the deployer of the contract is also gains a bunch of different rules. If we didn't have those, we weren't able to mint them. So that's pretty neat. Yeah, that's all that. What else can I show you here? I mean, there's yeah, like I said, more information on the validators. So also just generally about testnet, the way that we handle it is we want to have parity with mainnet most of the time. That means like we want to have exactly the same functionality and also the most realistic environment. So there's actually a bunch of validators that are also responsible for performing the chain upgrades. It also works through governance, the whitelisting, every basically process that you could do on mainnet also has to work on testnet. As well as the tools that you can use like oracles for price data feeds or implementation of graph services, subgraphs. Like our goal is it to if you're on deploying anything on testnet basically and it works and you've audited, you're comfortable that it's ready and you have a good strategy for launch. The only thing you have to do is basically change the RPC endpoints from testnet to mainnet, and then you could just deploy the same thing on mainnet. That's basically our goal and the mantra that we've been following. There is a situation, for example, right now where we are adding a new feature like the EVM extensions mentioned earlier, where they're only available on the testnet currently, because we have this process of just as you would be building a dApp or anything, we also do chain upgrades on testnet first, do a bunch of testing with internally, also with audits and other projects. Once we're confident, we move to mainnet and make a governance proposal. So yeah, you have like similar like consensus and block building happening on testnet. But yeah, we have also additional videos on like with more detail on eScan on YouTube, which you can follow if you're more interested in diving deeper here. Last thing, maybe a little intro, because now we're just working with the interface, but you might also want to do a bit more, I guess, querying and transacting from the CLI. So if you've if you're interested in that, definitely read up on our documentation here. You can install the Evmos binary quite easily with some prerequisites, but mainly you just have to check out the Evmos repo and hit make install and have Go and JQ ready. I obviously did this already, so if I just type in Evmos D, which is the Evmos daemon or the binary that's being executed, I get all the available commands. And I'll just show you a simple query that you can do to just symbolize how you can also submit these queries to testnet. So let's say you just want to query the balance of a certain contract or account. Let's say account, then you could do fmosd and then q for query, and then you use the bank module. Or if I just do q, then basically like it also always pops up, like you see all the different next, I guess, subcommands that you can use, and one of them is the bank module, which holds all the information of balances. So if I would type this in, then it says, okay, now you're in the bank module. Now you can check, these are the following subcommands, and we have balances. So I'm gonna do that again. And once I do that, it tells me, okay, I need to provide the address that I want to have the balances of. And the address has to be given in the bec32 format, the hex one. Hex is the Ethereum native one. Bec32 is the more Cosmos native one. So we also, the Evmos binary also provides some tooling. So you can do fmosd debug, it's a bit bigger, keys, and sorry, not keys, I think address, exactly. And then you can either provide the hex or bec32 format, and it will output like a bunch of different formats. It's the hex one, we want the bec32 in order to put that into the query. And if I execute this now, it will give me an error saying it failed to connect to the local host, because that's the endpoint, the Tendermint endpoint from Consensus that it defaults to. I'm not running a local node here right now. I could do this. I'll show you that in a second. We have time, but what we actually want to do is talk to testnet, right? So we can say we want to talk to the testnet node, and then now just image block daemon one, and then you can either use org for mainnet or dev, and then we use the Tendermint port and execute this. And what we basically did here is a query from the CLI, the testnet node at this address. And it shows me I have a balance of this amount of A ADO Tevmos. And just to confirm, this is pretty similar to the Tevmos that I have here. So just to show you, if I would look at, does this work again? I think, is it 18? What do we have here? Okay, so if we take decimals away, it aligns with like how MetaMask also shows you the full amount of Tevmos, not the ADO Tevmos. So yeah, this is just an example. You could also make transactions to the FMOS blockchain or network through a bunch of different modules, but that's not really the main purpose of this call, but just a little intro. Yeah, I think this kind of concludes the demo. I hope it helps you to get started on testnet. We do have a Discord server that you can jump into to ask questions. And yeah, definitely want to give you, support in building amazing projects. We're super excited about the having people work with EVM extensions specifically, but also happy to see any other ideas that you guys have. So that concludes the presentation part from my side.
Yeah, awesome. Thank you. Thank you so much, Dan, for this very detailed intro workshop. There's a questions from the audience that is it possible to buy Bitcoin from Cosmos using any Cosmos CW20 token? I guess that's
I
like
mean
not.
sorry.
Yeah, I'm just trying to say that's not like very relevant to the like EVMOs, but I guess it's an interesting question still.
Yeah, for sure. I mean, there's also, Cosmosm, which is huge in the Cosmos ecosystem. There's a bunch of bridges that allow you to buy, or I guess, swap Bitcoin. I would definitely look into those. I think Axeler probably allows this. Personally, I haven't done this myself, but I'm sure it's possible.
Yeah, I know there's another app chain called not Nomic. That probably can let you to buy Bitcoin directly as well. So yeah, but yeah, I think other than that, that should be it for today's workshop. Appreciate Dan for your time again. Very exciting to the very first Atmos hackathon on DoraHacks. And if you are builders, if you want to build something on top of the Atmos network, this is going to be a great chance for you to emerge in this very vibrant communities. So definitely sees as a chance, I would say. Yeah, cool. That's it for today. Thank you again, Dan. And looking forward for the whole hackathon. Yeah.
All right. See you probably tomorrow, right?
Yeah. Probably
Yeah.
tomorrow.
Right. Okay. All right.
Yeah.
See you guys.
Go on.
Bye bye.
Bye.